Hello, everyone. Hello. So, without wanting to turn this into a therapy session, hands up if you were doing some continuous delivery style work today. Keep your hands up if you had a conversation which ended in, well, that is bullshit, and wants to tell us about it. Because I want to tell you about mine. Guy at the back. What was your story that ended in, well, that is bullshit?
Probably me saying that's bullshit.
Yeah, absolutely.
Just today, somebody wanting to say, let's do DevOps. I want standards and procedures, and I didn't say that's bullshit. Talk about it.
You can think it. We're going to open it up to just thinking it.
So I had one where they wanted to get me in as a consultant to help them do DevOps-y continuous delivery stuff for their databases, and immediately they started saying, so what are you going to do? Let's spec out the entire solution from start to finish, and we will kind of put down exactly what you're going to deliver down to the finest bit of detail by the end of the X number of week period. So I was like, okay, I'm literally trying to move you away from waterfall.
Everyone else need to vent?
3-week testing cycle, and that's when they do their refactoring as well. Oops. Only 3 weeks.
That's impressive. So my one today was, so we're trying to do continuous deployment. We're trying to get the product teams to own their pipeline, and the current implementation is that the product teams can own a pipeline, but only as far as development. So they can do continuous deployment all the way to development, at which point operations have their own CI server and their own pipeline and their own set of operations, and they're going to do that. They're not really going to tell the product teams.
At the same place.
We should maybe talk later, but not say that right now. And I guess the other good one that I see is that there's a platform as a service, and people can use the platform as a service, but to get on the platform as a service, the product team has to buy the hardware, ship it to the data center, have it installed in the platform as a service, at which point they can do CF app push. So a process which should take, 3 or 4 seconds actually takes 6 months. Anyway, this is not what my talk is about. I just left work wanting to vent. Okay. So my hypothesis, the only way to effectively manage high-risk platforms is using continuous deployment. So it's not continuous delivery, it's continuous deployment. So every time there is a change, we want to push that change out, ideally without manual intervention. But people have different approaches to that. So I don't know who is using a PaaS at work? Who's played with the PaaS, pushed apps too? Okay, cool. So these are my PaaS basics. So the very sort of conceptual key basic that I have is, what is your target unit of currency going to be? So there's multiple types of currency that you can have as a development team. You could say it's a VM, it is a Word document with some code attached, and that is what the value deliverable of your team is. And what I think the answer to this question is that it has to be an app. It's just the app, the application code itself. Everything else you are wrapping around that is just implementation detail. So when you're trying to find a platform as a service, you want a platform as a service which will just deal with you as a developer pushing an app. You're not having to worry about containers or deployment documentation or all these sorts of things. It's just your code. Everything else is implementation detail, and something else should worry about that. So what is the relationship you want to have with your environment? So this, people may have seen this, but this is pizza as a service, and is a good analogy to how people should think about platform as a service. So obviously we've got the traditional on-premise, and at that point you're worrying about absolutely everything, all the way down the stack, cheese, toppings, absolutely everything. And what we want to move towards is a platform as a service, and maybe even software as a service, where we're only caring about the dining table in front of us, what's on the dining table. Everything else is someone else's concern. So the answer to this is, I want a pretty casual relationship with my platform. I want to see multiple platforms. I don't want to have to tell the other platform that I'm doing it. If I want to move to a new cloud, if I want to move to a new cloud provider, absolutely fine. And when people talk about wanting to be multi-cloud, being able to move incredibly quickly, avoiding this vendor lock-in that everyone's trying to get away from, This is what you want. And this really talks back to the first point about what is my unit of currency. If your unit of currency contains a huge amount of implementation detail, when you want to move what you're doing to somewhere else, that's a load of stuff that you're going to have to start worrying about again. You're going to have to change how your containers work, all those sorts of things. Really, you want to have your app, you want a platform, and if it's not working for you the next day, I'm going to ship it somewhere else. And it should be that simple. And this really talks back to where do you want to spend your time. So as developers, as businesses, what we want to be doing is creating and pushing features. We do not want to be worrying about platforms, having to talk to operations, that endless cycle of, I've done my 2 weeks worth of value, now it takes me 16 weeks, 1 year to get it into production. You want to be concentrating purely on writing apps, writing features, getting feedback as quick as you can, and getting those features in the hands of users. So I've got a couple of examples coming up, and I guess what is useful is just a bit of terminology. So the first terminology is, what is a BOSH? So a BOSH is a tool that we use to deploy platform as a service. And the example is going to be Cloud Foundry, but BOSH is the tool that says, hey, infrastructure as a service, I want to run this platform as a service. Give me all my VMs, connect them together, install the software that I need, and if I'm doing an update, I want to manually continuously roll out an update to all those VMs so that I get zero downtime and I have all of that end-to-end process managed for me. Also, what is a Concourse CI? So Concourse is a highly declarative CI server that we use a lot. It has lots of the modern patterns that we want to see in a CI server. There is no configurable UI, so everything that you do with the server is as code, which is exactly what we want. We don't want people going into CI servers manually changing configuration. Some guy goes on holiday and no one knows how the CI server works anymore. And the last thing is, what is a Cloud Foundry? So Cloud Foundry is the platform as a service that we use the most. It is an open source product, but it is supported and highly developed by Pivotal, who are based here in London, but also America and everywhere else. And this is the platform service that is going to give us the functionality from a platform service that we need. And the first thing it's going to do is allow us to do CF push my app. So it is going to take my application, just the source code. It is going to effectively give you a contract which says, give me your app. I will run it for you. You do not need to know how that works. It will stage it. It will do the routing for you. It will give you DNS. It's going to do a huge amount of things for you. But as a developer, you're just saying, take my app, run it. Jobs are good. It's also going to let you say this. So it's going to let you say, shit, it's a hit, I need more horsepower. So the only thing that you are going to do at that point is type CF scale, the number of instances you want, your app name, and at that point your app becomes 100 times more performant because there's just 100 more of them. This is totally true. You know it's true. That's exactly how it works. I'm keeping it simple. It also lets you do CF create a service. So it's going to say, I've created this application. I want a MySQL. I want a Redis. I want a cluster. I want a RabbitMQ. Give it to me. So it's going to go off and it's going to manage that whole life cycle for you. So it's going to create the instance. It's going to manage, hopefully, the backing up of it, all of these sorts of things. And it's going to present it in a very simple way to your application. So all that happens when your application's running, there's an environmental variable, and that just gives you the IP address, the host, any authentication details you need. And all you have to know how to do is interrogate your environment, get your configuration details, connect to your services. The rest of it is handled by the platform. And this is a turnaround time of ideally instantly, but anything up to a minute or two, which might not be your usual experience of provisioning services. And it's also going to let you create spaces. So it's going to let you have a platform that you could ideally run dev, QA, and production on the same deployment. At that point, you are no longer saying, QA is a bit like staging, and staging is maybe a bit like production. At that point, you can say the platform is identical. There is no difference at all. All that is being controlled is the security between the different spaces and the amount of resource that you're getting. So you could have quota limits for certain spaces. Maybe production has got more space than staging, but there's no reason you can't make them identical. So at that point, you throw out all that stuff about we have to test very late in the process. It's all got to be done in production. It looks sort of all right in dev. I don't understand why it doesn't work in production. All these arguments just don't exist anymore. And those command line tools are great. And you're going to use those as developers, and you're going to play around with it. But really, the way that we want to deploy applications is down a pipeline. So we need to have platforms as a service that's going to make it incredibly easy for us to develop a pipeline. So when obviously we're all hipster trendies and we're going to want to do microservice app and we're going to want 50 of them, if we can't very quickly build a pipeline that allows us to deploy those 50 apps, that's going to be a huge amount of work for us. So we need a platform which will give us this sort of interface. So in Concourse, this is really all that you give it. You say, this is my code, this is where my manifest is, and my manifest might just say a gig of RAM, you know, that sort of thing. And essentially, this is just doing a CF push for you. But the amount of configuration, the amount that you have to care about how the platform operates is still extremely small. So it's awesome. So now we've got that sort of understanding. We know how we want our platform as a service to operate, what we want our values to be. Let's get as a PaaS. So the first problem we're going to hit is that platform work is manual work. So there is a long legacy within particularly enterprises that the way that we do these sorts of things is manual work. So the first thing that people are going to want to do is start to click in interfaces, you know, do manual commands on their keyboard, do all these sorts of things. At that point, you're going to start to get these sort of superheroes. And these are the people that know how to do this stuff. There might not be very many of them. It's going to be very time consuming. So who's heard the monkey and the ladder social experiments? Awesome, I'm glad it's not everyone. So the experiment roughly goes like this. So you have a cage, you put four monkeys in the cage, you put a step ladder in, you put bananas on the top. So the first thing that one of the monkeys is going to do is go, I like bananas, so he's up the ladder, tries to grab the banana. At that point, the rest of the monkeys are soaked with freezing cold water. Monkeys hate freezing cold water for this argument. So what the monkeys that were soaked are going to do is attack the monkey that went up to get the bananas, because they know, you know, that they're going to be punished if that happens. So the next thing that happens is that you take one of those monkeys out and you replace it with a new monkey. So that monkey has never been soaked. So that monkey's like, hey, bananas. So he's straight up the ladder, tries to grab a banana, at which point all the other monkeys attack them. So those monkeys haven't been soaked, the new monkey hasn't been soaked, and then you go on until all the monkeys have been replaced, until the situation is that none of them have been soaked with freezing cold water, none of them have experienced that pain, but whenever them try and go and get a banana, they still attack each other. So if you ask the monkeys, well, why are you attacking each other? The answer is, well, it's just how it works around here. It's always worked like that. And hands up in a company who has that sort of answer. I was just trying to get some interactivity going.
Ask the opposite.
No. Okay. So problem number 2, we are a super special snowflake. So every organization has super special problems, and what they need to do is create their own PaaS. There are PaaSes on the market, but those PaaSes aren't good enough for me because we're super special. We have all these requirements which are different from everyone else. And that's what we're going to do. So then at that point, we're going to get some more superheroes, because those superheroes will have gone to some great meetups. They'll have learned all about Ansible and stuff, and they're going to create this amazing, you know, platform themselves. And at that point, you've got a load of superheroes. When they leave the organization, who is going to maintain that? Who is going to update it? Who knows how to operate it? Superhero work. So next problem, we are a risky business. At that point, you need a whole army of superheroes because you need compliance and operations and risk and logging and 24-hour maintenance and all that sort of stuff. So at that point, you've got this whole army of superheroes all have to interact. No one quite knows what's going on. There's a ticketing system. You have to pass requests between them all. Everything then takes months and months for anything to be achieved. And then what you also see is PaaS standing for Platform as a Silo. So you get this amazing new technology. You've got this PaaS that can give users apps in seconds and services. And what an organization wants to do with its history that no one really understands anymore is they want to wrap all their compliance models, all their ways of working around the platform as a service. So you end up my rant at the beginning, which is, I want to push my app, and the first thing you have to do is buy some hardware and ship it to the data center. So we need to avoid the historical debt attacking your PaaS and slowing the whole process down. Problem 4 is that when we get our PaaS and we do this manual deployment, what's going to happen is we're going to need to scale it. So our organization is going to think, hey, this is really useful, but we're in the UK and Hong Kong and China and America. Let's stick some foundations in all of those. And at that point, you realize that the platform as a service we're using is modern software. People are shipping, doing continuous delivery for this solution. So every 4 days, we're getting an update, which is either some exciting new functionality that our teams want, or more likely, a CVE or something like that. So at this point, we're into this cycle where we're getting new updates every 4 days, but it takes us 2 weeks to test it. Because we've manually deployed, we've scaled, we've distributed. So the teams that are responsible for giving the business the functionality, the cool new features that they want, is entirely consumed all day, every day, just doing updates. Just standing still, just keeping the thing compliant, the CVEs applied in the cadence that the business wants. And problem 5 is that it's expensive. And it shouldn't be expensive because platform as a service and tools like Bosch are going to say that we can deploy a platform within a couple of hours. That we can build it, we can experiment, we can destroy it, and the value should be charged in billable hours. But what happens in especially large enterprises is that they are used to a cycle where they get resource, and if they give it back, they won't be able to get it back again for 6 months. So what they do is they deploy in these environments so they can test their app, and even though they're not using them, they know if they release them back to the pool from a budget point of view or from whatever point of view, there's a good chance they won't get them back again. And it should be that they can get it, deploy it, delete it, save a load of money, and then the next day, if they just happen to need it, they'll get it again, but that's just not how it works. So when you start to deploy these foundations, you get a pattern where people deploy them and keep them up just on the off chance. So observations in the field. Organizations create their own PaaS. Organizations use an existing PaaS but deploy it manually. Organizations test a platform only once when it goes live, and you see this a lot. Before the platform's live, before real users are using it, they'll do DR testing and backup testing and all these sorts of tests that they want to do, but they'll do those once. They'll do pen testing, all these things that they do once, and then the platform is up, and then they're just patching it and stuff. But because it's so difficult, so expensive to rerun all those tests on a regular basis, they happen so infrequently that there's no real way of knowing that those platforms don't have serious issues, that the backup has stopped working or the DR test no longer works, these sorts of things. Organizations have a massive outage and can't recover in time. Organizations need multiple times a week. Cool. This is what we're talking about. So examples where I've seen this work well, I think. So I've got two examples. The first one is really an application example. So one thing that our organization did with Comic Relief is that we run the Comic Relief donations platform. So once a year, Comic Relief do a telethon. The platform is meant to collect up to 300 donations per second. And if we don't collect those donations, there's every chance that those people will not come back. So you get to that point at 9 p.m. on a Friday night. There's a campaign that's been running for 2 months or so. People are all different types of drunk. They're drunk on booze. They're drunk on emotion. They've just seen David Tennant with, in a very difficult situation in Africa. And they are like, I am here. I am going to donate. This is the right thing to do. I'm going 100 quid all in. So, and then either you don't take that money, you use 100 quid. At best, you email them on Monday and say, you're going to give 100 quid. And on Monday, they're not so drunk. And they're thinking, I might give £10. That seems more reasonable. I've got some work to do over here. So we run this platform. And because we're only getting that annual feedback loop, because the next time we get to have another crack at servicing those users is 1 year later, it's incredibly high risk. So the way that we mitigate this risk is that we use a platform as a service. We deploy that platform as a service to multiple infrastructure providers. So that's multiple AZs, multiple regions, multiple places around the world. We do it with open source, we do it with Pivotals. And again, because of this feedback loop, we want to do that. Hang on, what's this slide say? Yay, that's what I'm talking about. We want to do that a lot. So before the night, we want to have run that event, every day for the preceding 2 months, or once or twice a week. So we need a platform that we can deploy at this sort of scale down a continuous delivery pipeline. We want to click a button, wait 2 hours, and have a globally distributed platform that we can do a recreation of that night, because we need to learn all the things that could possibly go wrong before the night happens, because on the night we can't learn those things because we'd have to wait for another year. So it's crucial that we have a platform that can give us that sort of experience. So this is what it looks like. So Gartner did a case study on this a couple of months ago, I think. So even though we did this example in 2012, Gartner used this example as the best multi-cloud implementation of PaaS that they were seeing. So this diagram basically said that we have 3 front-end foundations, or shards as we would call them. They're globally distributed. They're multiple infrastructure providers. But as far as the application is concerned, they're all identical. So that is the experience that we give our CI servers or our developers, that even though it's Google or AWS or it's on-premise, the experience that the CI server and the developers have is identical. So their ability to push changes, build pipelines, all that sort of stuff is incredibly simple. And any of these foundations can take all of the money. So any of these can do 300 donations a second. If we lose AWS, if we lose Google Compute, as long as we've got one last man standing, we can take all the money, which is incredibly important. I think the other thing that is probably noteworthy mentioning about this is understanding the way that your data is going to work in this sort of setup is crucial. So the really key decision that we made with this platform, which has made it, I think, the most successful, is that we looked at our use case and we decided that Comic Relief don't need consistency in their data. What they need is availability. So the key driver is that the platform is up. We are taking the user data to the point where we can take their money. So the previous solution was a stretched Oracle rack setup. So at any point, they could see exactly the amount of money that had come in, and that was really important. But that was incredibly hard to distribute. If you wanted to distribute that sort of thing globally, yeah, there's solutions which have come out maybe in the last 6 months that do that sort of thing. But in the main case, moving to a eventually consistent model, having data which is eventually consistent and pieces back together over time, and sacrificing that availability, sacrificing that consistency to give you the availability you want is key. So I think it's important when you look at these multi-cloud things to really think hard about how your data is going to work. because it could be that, you know, a consistent data store is not what you need. And if you can move away from that, you give yourself all sorts of freedom to architect a different solution that can meet your goals in a much better way. Is that a pipeline? I don't know why that's here, but I just quite like this pipeline. So the example that is not an app. So we are a Pivotal partner, Engineer Better, who is Dan's company. He's going to speak later. We collaborated on this platform for a large global bank that is maybe, you know, from China, but headquartered in the UK. That's very great. So they're a global bank, and in terms of the number of developers that they have, it brings them into the top 10 development houses globally. So they've got a huge amount of developers all wanting to push apps, all wanting to have that CF push experience. I just wanted to drop this in. So this is totally irrelevant, but if you need really nice icons for stuff, like naming conventions or something, this site is awesome. This is going to bring you just a small bit of joy into your daily. So if you need to, you know, just brand something, you know, hipster animals, I recommend this site. So hipster animals. So this is our platform. So this was a large-scale Cloud Foundry platform, which was to a well-known public IaaS provider. I don't know why we can't mention Amazon. Anyway. So this is our platform. So to guide you through it, so we had multiple pairs working on this platform. So what we decided is that we wanted the ability to give every pair an environment. So when they were adding new features, everyone could have their own Cloud Foundry that was deployed for them when they were doing feature changes, doing deployments, testing continuous delivery, doing a AZ failure test. They wouldn't inhibit the rest of the team deploying. So this is obviously key to the whole process being automated, because we want these to spin up, they come into work, they wait half an hour or so, and they're good to go. So everyone had their own environment, destroyed daily, and we also had a pre-production continuous deployed environment. So there's no manual intervention at all into this. Whenever there was updates coming, they would be deployed to this environment. It would do all the tests. All the artifacts would pass through this pipeline, and at that point, that environment was also destroyed. So that was a cost-saving. We did this the first month, and it was super awesome, and everything stayed up, so we could be super thing. And then the bill came, and it was, hang on a second, this is too many tens of thousands. So an optimization we did is that we destroyed this environment after a successful test, but the CI service maintains that state. So it knows at the end of that process, this is the known good version of this platform. I have a copy of all the code that goes into deploying this platform, absolutely everything, and this is the last known good state. So if I want to deploy it to production, I know exactly what that is. I don't have to spin up this environment to test it and all those sorts of things. It's good to go. It's essentially sitting on head or master. Let's go. So next we have our production environment. So the first step is that we're getting constant updates from the vendor. So the vendor is updating the platform as a service, the deployment tool, the build packs, and the build packs are the things that build the containers around the applications. So all those sorts of things can come through with a different granularity, and this is the point where this is being triggered pretty much daily. There's an update, there's a CVE, there's a new feature, there's a new version, whatever it is, that is happening on a nearly daily basis. And then all the configuration is of code. So Cloud Foundry, when it's being deployed by Opsman, which is the Pivotal tool to do this, you have to go in, you have to configure all the tiles with AWS config or whatever those sorts of things are. So in parallel, it goes in and it configures all of those elements. And then at this point, essentially BOSH kicks in. So BOSH is slightly hidden in this process, but BOSH is the thing that does a rolling update to everything. So it will take a VM that has to be updated, it will drain it, move the applications to another VM, take it out the pool, update it, and then test that, that it updated successfully, move on to the next one, and it does that across the whole platform. So you end up with a rolling deployment, and that can be hundreds and hundreds of VMs with essentially zero downtime. And if it goes wrong, it's going to roll back and stop. And that is true of the platform as a service, but also of the services that you're using. So, Rabbit, MySQL, whatever services you've got running on the platform, it's also going to roll out those updates. So test-driven compliance. So one thing that's really important is that we convert all the tests that people would manually do, the smoke test, the tire kicking, the Dave going in to just check it looks about right. All of that gets converted into tests that can be executed. And wherever possible, we want all these to be executed in parallel. And the last thing that the platform did is test-driven resilience. So this last stage essentially goes into AWS, deletes an AZ. A bit of chaos monkey. So whatever you can do to assert that what the requirement you have for resilience and availability and what happens in a DR scenario, if that can be part of your pipeline, then that's invaluable, because every single time you push anything, you're asserting that backup, resilience, all that state that you're pretty sure you did like a year ago and you tested it and no one's really changed anything, so why shouldn't it still work? That is in your pipeline, and it is asserted every time anyone does any changes. So your delta between when it worked and when it maybe stopped working is as small as humanly possible, so you can work out who changed what happened. And one of the really important things about this pipeline is that we had some really great metrics coming out. So for all of those jobs, we had metrics coming out. So we can say, at this point here, someone pushed something and it made our deployment look like this. So whenever you're doing this sort of continuous delivery work, especially with platforms, because platform jobs tend to take a lot longer than an app. So, your app unit tests might be a minute, but deploying a platform as a service might be an hour or something. So you need to be incredibly clear at what point these pipelines start to slow down, because that eventually is going to become one of your biggest problems. So finally, some top tips. We kept a high line and stuck to our guns. So inevitably, when you start out with doing this sort of adventurous continuous delivery for something which is breaking a lot of conventions, a lot of norms, is that you're going to get so far, and then someone is going to come to you and say, we really need to get this out now. So can you just do some manual stuff and we'll fix it later? Like we really promise that in 2 months' time, we're going to come back to this and we're going to make it great and it's going to be awesome and you're going to be so proud of it. But just now, the business really kind of need this platform. So could you, just... So at that point, that's where you need to stick to your guns. And ideally, you're in a position where you can just say, nope, not going to do it. That you've got trust in your organization that that's the right answer. And I've seen that work absolutely. But also, if that's not going to work, you really need to start think about what is going to be the impact, what is the impact to risk to the organization, and how you're going to start to demonstrate that. How are you going to go to the organization and say, what you're asking is inherently risky, and these are the reasons why. And for example, if you're working in a financial institution, if you can give that to them in the metric that they really like, that would be great. So if you can go to them with a pound symbol and say, this is the impact of what you're doing, that's incredibly powerful. I think I'm becoming, in an organization currently which is, sort of bound with this sort of inertia, making those sorts of cost of delay, cost of risk arguments is incredibly important. So if you can stick to your guns, great. But if you're being under pressure, like how can you start to make these arguments which make sense to a business, not to other developers, but to a business who's trying to make business decisions? We did TDD. So I think when we started this, there were some people that sort of thought this was an ops thing and it wasn't a software thing. But fundamentally, and undermining my whole talk, this is just deploying software. Like, it's just the same. There is no different. If you're doing continuous delivery with software, inherently, this is not really that different. It takes a bit longer. It's maybe got a longer history of being manual, but fundamentally it is software development, it is software delivery. So BATS is a great tool for doing TDD when you're doing shell bash scripting. So that's what we did, because, and it's especially important in this situation because the feedback loops are inherently longer again. You know, deploying a platform may take an hour. So if you've got a bash script which is going to execute an hour down your pipeline, which is wrong, you're going to get an hour's worth of feedback and then go, I've got to go back, make a change. Did that one work? No, it didn't. So wherever you can, if you can start to bring in the sort of software engineering best practice, TDD, all these sorts of things, that's incredibly valuable. We focused on the what and why, not the how. So this really goes back to the monkey thing, which is when you're in an organization and you're starting to bring these sorts of changes, the change of way of thinking, wherever possible, do not engage with the how it is currently done. Do not go and say, can you tell me, you know, how I should do this? Oh, well, you need to work like this way. We've got this request for change process, and you need to do this because of compliance. You know, compliance. So the idea is, go to these sorts of stakeholders and say, what is your actual requirement? I'm not that interested in how you've implemented it before, but tell me, what is the compliance requirement that you've got? What is the risk mitigation that you've got to manage with the business? Don't engage with the how, because as soon as you start to engage with that how, it becomes a very long, lengthy conversation which ends in, you know, shouting and punching. We didn't have prod and staging named ends. So the environments that we had, so there's a whole sort of cattle versus pets argument that, you know, you want your environments to be highly disposable. You don't want them to be crafted. You want to shoot them at a moment's notice. So I guess this was sort of in a middle ground, because we did give them nice little hipster cute icons, but we shot them at a moment's notice. I mean, we had the solution, you know, to shoot those kittens in the face. It was great. Too much? I should have gone with a non-internet friendly animal. We deployed in sociable times. So this is one of the really key things that when it's not working very well, what tends to happen is you've got a test team that are working out an upgrade. They're recording some stuff in Word, and then they give it to the sort of the 24-hour ops team at 2 a.m. on a Sunday. They have to traipse in and start, you know, cranking through this because that's the safest possible time to do it. What we proved in this process is that we can do these upgrades in sociable times. Because we're doing these updates on every single commit, we're doing it continuously, we've got a really high understanding of the likeliness that it's going to succeed, that we can start to do these things at sociable times. So we can stop having support teams that have to trundle in the middle of the night. We can redivert that resource to working on the platform, adding new features, doing all these sorts of things. And we constantly optimize for short feedback loops. So after the initial sort of getting the thing working and deploying, nearly everything we did was working out how to get the feedback quicker, how to be able to do multiple tests or deployments a day, how to stop it being a 2-day process. How can we get a feature in the morning and by the end of the day either have it in production or have a very good reason why it shouldn't be. So the investment in that constantly working out how to make the whole process quicker is crucial, again, because these platforms tend to take a lot longer. I think that's me. Thank you very much.